topic is next topic, unit number 5, expectation maximization algorithm. So before starting with expectation maximization, first we'll see what is the estimation. So estimation with respect to our machine learning is what estimate our expectation, what we are expecting from machine learning from these machines, and then classify the data into some classes. So the process is what that we are preparing some model, machine learning model, right? And then we are estimating that what will be the output of this machine learning model. So probably just take as an example, we want to classify the data by using this machine learning algorithm, right? So first we will estimate that what we'll expect, that which data belongs to which class. That is generally the feature values we will extract, right? And based on the feature values, we'll prepare any rule that if this is less than or that is greater than, if number of multiple rules will develop together. So that is what our model and our estimation. And now what is maximization? So whatever we estimated should now be maximized. So we have prepared model, we have estimated, and we classified the data. Now whatever the data we classified, the result which we obtained. So based on that result, we'll find out that as per the estimation the things are done or not. Obviously it is going to be done because model is prepared in that way. Now our task is to maximize this result, maximize this classification with respect to the features. So it's like providing a refinement or more clear formation of the classification task or whatever the task for which the model is designed. So now we'll see how it works. So from given data, expectation maximization learns a theory which tell you that how each example to be classified and how to predict the feature value of each class. So through expectation maximization, we learn a theory. That theory will inform you that how each example is learned by this machine learning algorithm and classified the data. That is how to predict the future value of each class. That how that model works. That will learn by this expected maximization algorithm. So for this, it starts a randomly classify the data and repeat the two steps until a clear result is formed. What are those two steps? They are ahead. So in or in expected maximization, it starts with a random parameters we can say, right? Or randomly as per your expectation, whatever model you have prepared, right? And in further iterative steps, we are refining our results. Clearly, formation of the results will be done. These two steps are capital E and capital M. The E is that is expectation. E stands for. So it's classify the data using the current theory. Current theory is that whatever the present model prepared with respect to the parameters, with respect to the rules of the features. That is our current theory. Now, generate the base theory. Next step is capital M, that is maximization. Now, here we are improving our results, modifying our result based on whatever results we have obtained with respect to our current theory. So, it generates the base theory using the current classification of the data. So, our base theory will be what? Whatever the current theory we have developed through the model, we are doing refinement to that. So, our current theory is what? That is rule based. Let's take an example. Based on the feature values, we have designed a rule, classified data. In maximization, we are changing these rules so that the result will be get improved or enhanced. That is what the maximization. So step E generates the expected classification for each example, and step M generates the most likely theory given the classified data. That is best theory we can give with respect to classifying the data. So it has an applications in natural language processing, artificial intelligence, various other areas. So now assume that example we have 2 points, capital C1 and capital C2. These are the naming we are providing to the points. Now assume the bias of C1, that is the first point, is theta 1. That is the probability of getting head with respect to the C1 point. Next, assume the bias of C2, that is the second coin, is theta 2, that is the probability of getting heads with respect to the second coin. Now, in example, a very simple example is taken for better understanding. A coin is taken. Now, probability of head and tail without bias is 0.5 of each. So for each coin, we are giving some notation. Coin 1 will be C1, coin 2 will be C4, coin just that's it. Assume the bias of C1 theta 1, that is the probability of getting head. Same C2 theta 2, that is probability of getting the heads. Now we want to find theta 1 and theta 2 by performing the number of trials. We are performing now number of trials to find out theta 1 and theta 2. So what is theta 1 and theta 2? Probability of theta 1 is probability of getting head by coin C1 and probability of getting head by C2 coin, that is theta 2. That we are doing by performing the number of trials. So trials are with coin tosses. So first experiment that we choose 5 times one of the coins and we toss the chosen coin 10 times. So we are having two coins C1 and C2. So we are choosing 5 times one of the coin. Two coins, each of them will be get selected 5 times. Right? C1 will be get selected 5 times, C2 will be get selected 5 times. So this will be total 10 times, right? So after selecting, we are tossing that, right? So there will be total 10 toss of the coin. Chosen 5 C1 and chosen 5 C2. So let's say we are having the 5 times one of the coin is chosen. It's not both are 5 times. In 5 times, so as an example elaborated here. So these are what? These are the 10 tosses and 5 times we have done this task. And we chose randomly one of the coin. So which coin is chosen for the trial of 10 time is known in this experimentation. So a nomenclature A and B is used instead of C1 and C2 in this. So coin A and B, these are the two coins. So let's say for first time coin B is tossed and these are the results, right? So it first appears head, tail. In this way it will be result is represented. Now second time choosing of the coin, let's say now choose coin is A1 and the results are 4 head, 1 T and the 5 head. 10 times tossing of the coin. Third, fourth and fifth in this way. So 5 times choosing one of the coins. So out of that 3 times we have choose A and 2 times we have choose B. So same table again pasted here. So first now B, with respect to B, first pattern, that is the theta 1. Now we are calculating the probability of getting heads by the coin C1. So our C1 coin is named as B here. So C1 is equal to, for first pattern we are talking about. Now this is our first pattern, first sequence, first trial we can say. Theta 1 is equal to number of heads using C1 and total number of flip using C1. So total number of flips, denominator, that is 10, and number of heads, these are the total 5 heads in first pattern observed, first pattern as a result, first sequence as a result. So the probability will be 5 by 10 of getting head by C1. Now we'll observe the second pattern, that is with respect to the coin A, that will lead to our theta 2. So this will be what? That is number of heads, same formula with respect to C2. So with respect to the second sequence, 9 heads out of 10. So 9 by 10 will be the probability of theta 2. Okay. Next is now labeling of coin. Now here in this example, whatever we have discussed, that is labeling of coin was there. So we know here the label. Label of coin is known to us. So from this, we have computed the probability of each of these C1 and C2, coin A and coin B. So first chosen coin B, 5 heads, 5 tail. For coin A, 9 heads and 1 tail is here observed. For coin A again 8H2K. In this way the stable is prepared coin A and coin B. So with respect to coin A, total 24 heads and 6 tails. With respect to coin B, total 9 heads and 11 tails. Right? Now combining all these 5 runs, we can see 5 trials of choosing the coin and 10 times tossing it. We are getting the bias theta 1 and theta 2 by considering complete experimentation. Theta 1 is equal to total 24 heads divided by total number of samples. So total numbers here is 24 plus 6, that is 30. So for bias probability of getting head by first coin C1 is 0.8 and theta 2 is 0.45, that is 9 head and 11 tail. Right? So this is what the computation we have done. Now assume a more challenging problem. Right? That is the instead now labeling is not provided. That we do not know the identities of the coins used for each set of tosses. So we treat them as a hidden variables. So labeling is not null and that is termed as a hidden variable. So now which coin is selected that is not known to us. So these are the 5 sequences we will get. 5 times the sequences of 10 trials we will get. This is removed. Which coin is this A or B? Now assumption QA is equal to 0.60. That is probability of getting head for coin A and theta B is 50. That is for getting head for coin B. Okay, so what is this actually? This is our assumption. We don't have now. We don't have the data of which coin is that we have tossed. So we are assumed here. Now these figures are not computed. This is just the assumption. Assume 0.6%, 60% probability of getting hit for A, 50% probability of getting hit for B. So in first round, 5 heads and 5 tails are there. So now this representation is the last output actually. So here explain the steps 1, 2 and 3. Right? So with respect to this slide, just look at this highlighted in the red box. Outline red box, just look at here. So here is what that assumption is written. That is theta A is equal to 0.60, theta B is equal to 0.50. So this is just the assumption that we have done before concluding the estimation and then maximization. Okay. Look this box only. We'll go again back to this slide. So now compute the likelihood using binomial distribution. First step is what that is we have done. I will just speak again about this slide. So if you'll observe that this is our assumption. This is the first step. Started with some assumption on the problem which is discussed at the start. That is explanation of the problem is given at the start. Then we are estimation step. So these are the estimation step result. Coin A and B is table and this estimation result. Then after getting the result, we are leading to the maximization. That is the third step. Okay. So now we are at the first step and that we have given the assumption of 0.60 and 0.45. Now compute the likelihood using the, so for computing likelihood we use the binomial distribution. The formula is P of k is equal to theta raised to k in bracket 1 minus theta raised to n minus k. So the probability of getting the head of first coin, then then 1 minus probability of getting the, now the theta k is what, that is probability of getting head of the first coin and 1 minus theta raised to n minus k to the power n by 1 minus theta raised to n minus k is what, that is n is equal to total number of tosses. So in our case total number of tosses are 10, okay, minus k. So here k is the value of head or tail, but we are talking about heads only in our, as per our problem, right? So the formula is P of k theta raised to k in bracket 1 minus theta raised to n minus k, where theta k is the probability of getting paid by coin, first coin, 1 minus theta the probability of get to the power n raised to minus 1, where n is the total number of tosses and the number of heads appear. So first pattern observed. So as we know the first pattern, this is considered. Okay. This is our first pattern. In this first pattern again I will tell you 5 heads and 5 tails are there. So first pattern 5 heads 5 tails. So likelihood of capital A is equal to, that is theta A is equal to probability of first coin, that is A coin is considered. We are calculating of both because we don't have the coins, name of the coins. So h raised to h, so this is theta raised to h, so head raised to head. Yeah, theta is over here is for getting the heads. 1 minus pa of h raised to 10 minus h. So theta is what? Probability of getting head by the coin A. Okay, that is what the likelihood. So what we are assumed that theta A is equal to 0.6 and theta B is equal to 0.5, that we assume, right? So just putting the values now, 0.5 is PA of H raised to H. H is what? Number of head appears. So 5 heads appear. Okay. 1 minus 0.6, 10 raised to 10 minus 5, 10 number of tosses, 5 is the head. So this is the result. Now likelihood of the B, that is theta B, is equal to our B coin. So for that theta B we have considered as an assumed as an 0.5. So by putting the values 0.5 raised to 5, 1 minus 0.5 raised to 10 minus 5, the result is 0.000975. Okay. So this computation of likelihood using binomial distribution, this is the 10 sequences, which one is from which coin, that is unknown, right? So that we have assumed the theta A and theta B as 0.6 and 0.5, and we have computed the probability of getting hit by this by the first coin, by the A as well as by the B, that is based on theta A and theta B assumptions. Now for placing the likelihood A and B in probability form, we normalize it. So normalization is by using A by A plus B. Placing the likelihood of A and B in probability form. So to replace that in a likelihood into a probability form, we normalize it by this formula A divided by A plus B. So for A, the result is A divided by A by B normalization, putting the likelihood of A divided by addition of both likelihoods, the result is 0.45. So this is what the 45% of the probability. Second, that is capital B normalization is B by A plus B, and that is 0.55. 55% probability. This we have normalized, and likelihood of A and B is converted into probability of A and B. Now estimate the likely number of heads and tails for the first toss. So for A, head. Now for capital, now what we are doing, estimating the likely number of heads and tails for the first toss. So capital H is equal to, for first pattern, there are 5 heads and 5 tails. Okay. For A, capital H, total number of heads is equal to probability of A, first coin, that is 0.45. Okay. Into 5 heads are there, this result is 2.22. Now with respect to the first sequence, total tails are 5 and probability belongs to B coin is 0.45. The result is 2.2 only. Because both heads and tails, that number of coins are 2.2. So that is first sequence, that is for capital A. Probability of capital A was 0.45. Now with respect to the B, consider that first sequence, the first selected coin is B and toss the same number of times. So heads will be 0.55 into 5, that is 2.8, and tail is equal to 0.55 into 5, that is 2.8. Now, in this way, first computation is provided while this box. So this is up to this is fine. This is assumption. These are our experimentation results of the sequences by the coins. The estimation step is that coin A and coin B 0.45 into A and 0.55 into B. So this first row we have seen in this previous slide. 2.2, 2.2 for coin A, 2.8, 2.8 for coin B. 2.2, 2.2 head and tail, 2.8 head and tail. Okay. So this is the first row computation. Likewise, we need to carry out for the second sequence, third sequence, fourth and fifth sequence. So directly the results are written. Calculation is not provided here. Right? The calculation will be what, that is with respect to this. So from here it will start the calculation. So this three slides for computation of the second, third, fourth, fifth, you need to repeat it. So we'll get this is what 0.80. These are what the estimated values. That is what not estimated, calculated values. So we'll get this results. So if you observe with respect to coin A as a complete will be 21.3 heads, 8.6 tails. For coin B 11.7 head and 8.4 tails. Now we are computing the theta A, that is probability of getting head for coin A for the combined experimentation. That is 5 times different coins are taken and experimented. The third step is what, that is the maximization step. In maximization step, theta 1 comes, theta 1 is equal to probability of getting head by coin A. So total our head and tails are 21.3 and 8.1. Out of that, heads are 21.3. So the result of theta A is 0.71. Likewise, theta B is equal to 11 point, because 11.7 times head appears out of total as a denominator, and the result we got theta B, probability of getting head by coin B is 0.5. So this theta A and theta B we got. Here 0 is used because it's in a starting initial phase. So 1 will be what, that is updated 1. So the notation is given as a 1. And again, if you know the complement is written on the theta. This is the notation. Theta A 1, that is first iteration result, 0.75 and 0.5. Now again this weight will be given to the theta 1 and theta 2, and next iteration will start from here. Theta A will be 0.71 updated values, theta B will be 0.58 updated values. We'll go through this again, we'll again do the estimation step. These values will be get updated, these results will be get updated, and from the updated result again we are finding theta A of 2, theta B of 2. Right? So this process will be get continued. So this process, this will explain you after this. So now replacing the estimate theta A of 1 and theta B of 1 with the previously assumed theta A of 0 and theta B of 0. Again repeat the step 2 and 3. Step 2 is the estimation, step 3 is the maximization. Now to estimate the new values of theta A and theta B, do this continuously till we get a constant of same values of theta A and theta B. So till now we need to do repeat this continuously, and when to stop, when the whatever the present results and the previous results are the coming same every time, right? At that step you need to stop. That is step number, let's say 4 and 5, the result are same, then we need to stop there, because after that the values are not going to be get changed. After that the probabilities of theta A theta B will not be get changed. So do this continuously till we get a constant of the same value with respect to present and the previous iterations. So for this particular example, when we get with the 10th iterations, it is written. After 10th iteration, we will get the result as theta A is equal to 0.80 and theta B is equal to 0.50. So these are our the maximum value we can see. So it is converted into the next step, that is the fourth step. Continue this 1, 2, 3, right? When we will get the constant values of these two or the same value, then at that time we need to stop. Now with respect to this particular example, when theta equal comes 80.80, theta becomes 0.50. 10 means it's enough. After 10th iteration, you will get this value. Okay. Then we need to stop here. So that is what the maximization with respect to our problem. That we have started by assuming theta A is equal to 0.6 and theta B is equal to 50. So that is what the expectation maximization. So what we have seen in next topic is Gaussian mixture model. So in a part I will go through this very small topic. At first starts with the estimation, then the model with the result. Then update the model by doing the maximization. So how we can perform the maximization with respect to the traditional machine learning algorithm if we are working with the feature. For feature we are deciding some rule, right? Some rule, and that is leads to a model. So in maximization we are changing means that parameters are get changed to get the more clear form of the classification, right? So the working of that is here. As an example, we have taken toss of the coins. The result is here. Question is that experiment is what choose 5 times one coin, right, and toss this coin 10 times. So if the results are known, then it is quite easier that you will get to know. But if the results, the labels are known, then you will get this results. If the and we can update it with respect to coin A and B because we know which belongs to which coin. Okay. So what we have done, that is if the labels are unknown, then we need to follow this process, that by assuming some values at the start. Assumed values are get updated by calculations. The calculation is provided here in this. The calculation of likelihood we are doing with the standard formula, that is the binomial distribution to compute the likelihood. So if theta 1 and theta b are confused, just consider that replace probability of A is equal to that probability of happening of that event into probability of not happening of that event. So as we have learned that probability of, let's say, P and Q are two events, probability of P is equal to, that is probability of P into probability of 1 minus P. Probability of 1 minus P, that is not happening of that event. That is only just replaced with the theta notations. Computation is performed doing the normalization, that is it's a standard way, that is the likelihood is get converted into a probability form. A by divided by A plus B. So this way we are computed for this all sequences what we are having, right? And we are leading with respect to the updation to the theta A and theta B. That is the maximization we are done. We need to continue this till saturate or till get the constant values of theta A and theta B. So this is estimation and then maximization of that. So that is the estimation maximization. Now this is the next and last topic, that is the Gaussian mixture model. So unsupervised classification. So instead of theory, I will start directly with the example of Gaussian mixture model, how it works. Okay. So let's say that is one problem we'll consider, that we have a group of students. Okay. That is coming from either two classes are there, gifted classes or the regular classes in a school or college, right? And we have a group of students are here coming from either the gifted classes or regular classes. That is from their previous academic year. Now, the question is that, example is that students who had high score in last year exams were assigned to the gifted class. Those who are having high scores in their previous academic year, that is last year's exam, were assigned to a gifted class. And the rest of the students, those who are not having the good marks in the last year exams, they were assigned to a regular class. Okay. So, we can use the histogram of the last year's exams scores to estimate the threshold to eliminate the two classes. So, what we are doing, what the last year results, we are showing looking in terms of a histogram. So, number of students and the school. And this is to estimate the threshold to decide that which class the student belongs to, that is for the regular class or the gifted class. Let's say this threshold point is marked at the red arrow. So this less will be the less score will go to the regular class and the right score will go to the gifted class. Now give Gaussian mixture model. Now a problem statement is what, right? That is students are coming from different regular classes. Now to promote them for the regular class or the gifted class, we are looking at last year results. Based on that results, will decide that some threshold that is for gifted and for the regular class. So Gaussian mixture model is what? It's a model that assumes data generated from a mixture of k Gaussians, a bell shape k Gaussian component, that is a bell shape. If you observe, that is a wave we have seen in a normal distribution, right? That normal distribution is a bell shaped curve that we have seen. So is a Gaussian mixture model is a model that assumes data generated from a mixture of k Gaussian bell shaped components. So the formula for this Gaussian mixture model computation is that P of x is equal to summation. This sign is for the summation. That is from k equal to 1 to k. Wk into g of x by mk comma vk. Now, as this is we know that is in previous lecture we have seen, so just the symbols are different one. Vk is what, that is the variance of the Gaussian component. Gaussian components are what the marks of the student are your Gaussian components. So variance is computed with respect to this data values. A data values is what the last year's result, exam result of the students. MK is what, that is mean of Gaussian component. Right? So we are having the numerical values, that is the result of the students. So MK is the mean we can compute. So G of, now here X is what, the X is the data, that is the exam score, right? Wk is the weight of the Gaussian component, okay, and K is what, that is the sum of the components, that is K equal to 2 in this example, that is gifted or the regular classes. As we are looking, this is the unsupervised example, right? So let's say an unsupervised example, we are having two clusters K1 and K2. One is for gifted class and one is for the regular class. So I think you cleared with this formula right now. Now, the Gaussian function in the matrix form, the representation of Gaussian function in the matrix form, g of x by m comma v. This is what g of x comma this particular part, that is g of x by mk vk. So that further expanded into in terms of matrix form. So x is the data value score, m is the mean that previous we have seen, and v is the variance. Now this complete g of x by m comma v is what, this is the probability of x, that is the exam score, belong to a certain component, that is mean and the variance, this particular data score is equal to 1 by 2 pi raised to n by 2, right? So we can say this is the square root n by 2 and square root of this also into cardinality of v. So here, this complete this particular portion 1 divided by 2 pi and kinetic v by raised to n by 2 is here n refers to the number of feature sets. In this example, n equal to 1. N is represent the number of features. Okay. If it is 1, then it is square root. So n is equal to 1. That is cause the we have used the exam score only as a feature in our example. Right. So this n will becomes 1. This is 1 by 2 already. Pi, that is standard pi value. Exponential of in a square bracket 1 by 2 x minus m t. X is mean, m is the x is the data score, one score let's say, and minus m is the mean. Raised to t, that is the matrix representation. V inverse, that is what the variance inverse, and in bracket x minus m. So m is the mean of the matrix of the exam score in a component, and V is the variance. Here this V is the variance of the exam score in a component. Okay, so this Gaussian function in the matrix form. So steps of Gaussian mixture model. Step 1, that split the histogram into two equal portions. That is, each portion refers to a Gaussian component representing either a gifted or the regular class. So now we are moving ahead with how working of this Gaussian mixture model. With respect to the examples which we discussed in the previous. So first step, that is split the histogram into two equal portions. Each portion refers to a Gaussian component representing either a gifted or the regular class. The first step, that is representation of the data store into a visual representation of histogram type of representation in histogram. Step 2, that is initialize the mean and variance in each that component and assign the weights as a 0.5. So, step 2 is that initialize the mean and variance in each component and assign the weight as a 0.5 because we have only two classes. Now, in formula, WK was there, that is K was 2 for us, that is with respect to the two classes, regular and gifted. So, W1 is 0.5, W2 is also 0.5. So, that is assumed here that because we are having only two classes, so that is weight will be 0.5, that is equal weight for each class. Third step, that calculate the new mean and variance and weight for each component. Calculate the new mean, variance and the weight for each component. That is equations are coming in the next slide to compute that computation for the how to compute the new mean, variance and the weight for each component. Repeat the step 3 until the computed parameters are close to their previous value. That is again, that is the compare the the recent values you got with the previous value. When they are close to each other or the same with the previous and the present are the same, then stop. So now we are moving ahead with respect to these steps and with respect to the histogram of the exam score is in front of you. So total number of students, that is 0 students, 10 students, 20, 30 and 40. So 10 students scores marks as an 40. 20 students scores as an 50. 40 students score no any mark of 40 students. The number of students and the exam score. So that is 10 students score 40 marks. 10 students score 40 marks. 14 students score 45 marks. 12 students score 100 scores by the 12 students. The exam score is 100 for the 12 students in a class. The total number of students are 259 with the addition of these. Total 259 students and their scores are represented in histogram. Bunch of the result, number of students, y-axis belongs to number x, y-axis and and now step one, that split the histogram, that initial split point. Initial split point, that is taken the mean value, right? So that is 40 scores by the 10 student, 40 marks you can say, exam scores by the 10 student, 45 by the 14 student, right? It continues with the 100 marks by the 12 students, divided by the total number of students, 10, 14, 19, 12. So this total number of students are 259. So the results come 71.6. That is the initial score. So obviously the scores less than 71.5 is treated as the first component, greater than 71.62 that is treated as the second component. The first component obviously for the regular class and second component will be for our gifted class. Now step 2, initialization. So two components we have decided, that is less than 70.60, 71.62. So these are the scores. Those who are scored less than, average score is less than 71.7 with respect to this data values are here. So we are computing for first component mean value. The mean comes 56.21. Right? So computation is provided here. So variance is 78.62. Variance formula, that is it covered already. That is here the 10 into 40 minus the mean value and square of that. Right? So 45 marks minus the mean value raised to 2. Variance comes 78.64 with respect to first component. This is the threshold red line that we have considered 71.62 as a threshold. Now, for second component. For second component again, M2 and V2 is computed. Same way like in our previous slide, first component. Mean M2 and variance V2. Now, with respect to the so after this first component M1 V1, M2 V2 for the second component. Now next is that getting to the third step, that is since we have initialized the three parameters for the two components. We have to conduct the iteration to the compute the new values for each of these three parameters. Right? So these three parameters are what, that is the M and V and our threshold, that is the 71.62 threshold. One parameter, second parameter, that is mean and variance for component 1, third parameter mean and variance for the second component. So these three parameters for the two components. So we have to conduct the iteration to compute the new values for each of these three parameters. Now third step. The third step is that just wait for me. Okay. So compute the new weights now of these parameters. So this is the equation to compute the new weights. Recalling the parameters, that is W K new, that is the new weight. Formula is, that is 1 by n summation 1 equal to 1 to n summation 1 to n uh, wk, that is no explanation is provided. I will read one by one. W of k new. Now we are updating the weight. Formula is in front of you. Formula is explained very well through this slide. 1 by n, n equal to 1 to k, where n is what the number of students. So in our case, total 259 students in our example. So wk, that is the weight either w1 or w2, that is 0.5 that we have. Equally, we have provided the same weight as we are having two classes only. So w1 for 0.5 and same for second class w2. Gaussian of this xn by mk vk is equal to this mk vk, that either two components we are having, right? So m1 and m2 values for mk, and for vk, that is the variance. Two variance we have computed v1 or v2 with respect to the component 1 and with respect to the component 2. xn is the exam score, right? 40 to 100 marks from the student of the total 259 students. X, now this denominator is also the summation 1 to k is equal to 2, because we are having the two classes. So this is the formula for computation of this new weight, W k common weight. Equation to compute the new weight. Next, iteration 3, next step is now to compute the weight W1. Let's solve the numerator first. Now we are computing the W1 through this formula. So g of x by m1 v1, that is computed first. So to compute w1, process is first compute g of x of m1 v1, mean and variance of first component x in our exam score, is equal to matrix representation of this form. This formula is already explained in previous slide. That 1 by 2 raised to 2 by pi 1 by 2. Okay. So this 1 is actually n, right? So in our case, that is n equal to 1. Exponential of this 1 by 2 x by m1 matrix, right? So putting the values, 2 into pi value 3.14 into variance, 1 first component variance is 78.64, right? Whole raised to 1 by 2. Exponential of x minus, this is 1 by 2, so 2 is get multiplied here with respect to variance. X minus 56.21, that is the mean first component, right? Second component. So substitute these x values, 40 marks, 45 marks, 10 marks, right? 45, 10 marks, 50 marks, up to 100 marks. So we will get x of m1 comma v1 is equal to, and putting these values we will get these results. Okay. So next slide now. Now we are computing g of x by m2 v2. Previous slide we have computed m1 v1. Now for m2 v2. This calculation we are doing to compute this new weight. X of m2 v2, same, putting the values m2, that is the mean of second component 86.68, and variance of the component, that is 52.16. Putting these values of x, that is score of the students, we will get the result. First 5 times 0, then the next is 0.0001. You can cross check this after the lecture, or I will share you this also as well. Now combining these two to compute a new weight, w1 of 1 comma new is equal to 1 by n. So here the computation is provided, 1 by n is the 259, so 1 by 259. Okay. Exam first score, that is total 10 students. So 0.5 into 0.008, divided by 0.5 into 0.008 plus 0 into 10. That is the summation actually. So the last results, to just verify that with respect to W1, we'll see that last four results are 0, right? So here the last four results are multiplied with respect to the 0. That is 0 is of what? That is 0 of x, 0 of x by m1 v1. X by v1 coming 0, 1, 2, 3 and 4. And with respect to the second, that first 5 are 0. So this is with respect to the first component. Now this is with respect to the second component. The second component, now this further statistics are provided with respect to the marks and everything, 1 by n number of students. So first 5 were 0, that is 1, 0, second 0, third 0, fourth 0, and fifth 0. Okay. Computation in the previous slides are placed here and the result is 0.506. A very simple explanation is there, don't be get confused, right? Just after sharing, go one by one with respect to the slide. Very simple example is taken, right? And much more easier way to represent the formulas are also. Okay. So after computing this W1 new and W2 new weights of W1 and W2, we'll get the result. This is the first previous point 0.5 and point 5. Then after step 3A will get updated result 0.494 and 0.506. 0.506, 0.494. Now let's work on the mean M1 and M2. That is the second parameter. So weight M1, V1, M and V. Weight W, M, V. These are our three parameters. We have updated our first parameter W. Now we are updating mean second parameter and then we'll update the next, that is the variance. Now this computation for the new mean k comma new. So the formula is equal to n equal to 1 to n. This complete we have done in previous here. We have calculated, right? This particular portion into xn. Again denominator is the same. Denominator is the same. This is pretty much the same as we computed the weights. Pretty much same as we computed the weight in the previous slide, that is new weights. So now further elaboration to the computation. Now let's work on the numerator of m1 comma new. So this is the numerator. Same like our weight computation into xn, right? So this is the same and we are multiplying it by the xn. So the result we got 7728.26. The detailed calculation is provided in this slide. Xn is whatever the number of students that we have multiplied here 10, 14, 19. So the weights, in weights we are having only with the this 10, 14, 19. So here we have updated, that is multiplied by the score. X is our actually data value, data score. Scores are multiplied with respect to each. So we have the result 7728.26. So next, that is the computation of M1 new followed by denominator is what 128. Now denominator calculation. So that is without the multiplication of this xn. Same without the multiplication of xn. So this multiplication of xn 40, 60, 80, this part is get removed and we got the result by 128.06. Okay. So by putting into the formula these values for mean computation, right? So we got the result as a 55.45. We see the computation of M2 new since it can be done in a similar way. Right? So the and one new, the same will be for the component 2. So that value will come 86.46. 55.45, that is for M1, and 2 times 86.46. So if you observe, that is before iteration, this was the two parameters, weight and the mean. After iteration, parameters W and mean values are changed, that is updated, we can say. Now we are looking next, that is third parameter, variance. Now this is again the same like our weight computation for the variance. So variance of k comma nu is equal to, same formula is there of the weights. Instead of this, that is last is what that we are computing variance. So variance is what, that is the data score minus the value, that is the mean value. Data score value minus the mean value. So that is the same as like our weight computation or our previous, that is the mean computation. So first we'll compute the numerator for the new variance. Last, just look at here, 40 minus 56.21. 40 is the score of the student, x, and that, let's say x1 is this, x1 is equal to 40 minus m1 is what, that is 56.21, that is the mean value, square of that. 45, that is the x2, second student, for second bunch of student 14, so it is multiplied at the end 40. 45 minus 56 is the square. To detail the statistics computations with respect to this numerator, and value come 11,006.97. Okay. And likewise the denominator, just removing this, right? It's n minus m1 square. This value is 85 point, the result is same 128.06. So if you observe, I'm just going back, 128.06 was the same was there with respect to the denominator. Look at here, 128.06. This particular denominator is same there also. So that value is same, right? So we have previously computed it. So the result will come 85.95. So we skip the computations of the way2 common u because the same way it will be get calculated, right? So updated variance, new variance we can say in 85 and 0.95 and 57.60. So next is, that is we can keep doing the iteration, replace the 6 new parameters in the aforementioned equations until there is no significant change. So after step E, A, B, E, and C, we got these values, 6 total values, 2 for weights, 2 for as we are having 2 components, 1 and 2. Step 4, that compute the exam score threshold. The threshold can be found when the following requirements fulfills. That is the data points which is located in both the first Gaussian component and the second Gaussian component. The first Gaussian component, that is W1 into V of x by M1 V1, with W of is equal to W2 of V of x by M2 comma V2. Threshold can be found when the following requirements fulfilled. Then both will be equal. Right? Both will be equal because two components we need to declare based on some threshold value. That is the data point which is located in both data point which is located in both the first Gaussian component and the second Gaussian component. To compute the exam score threshold, threshold is showing you that is as 50% of the students we need to promote for gifted class and 50% students for regular class. So that both should be equal. Equal number of data points will be there in both the classes. To compute the exam score threshold, therefore, the equations for that. So W1 dot g of x and m1 v1, that is left hand side we will see now. That will be this W1 of 2 pi I 1 by 2 exponential of this 1 minus 2 x minus m1 t, that is the matrix form of this equation, is equal to with respect to the W2. Now this computation is done, that is this W V2 will go to the right hand side, left hand side and right hand side. Normalization is done, and at the end we got this W1 V2 divided by W2 alternative V1 1 by 2 is equal to this exponential form. Don't be get confused. This explanation is given at the earlier in this presentation. To compute the exam score threshold, take the natural log on both the sides. For this equation, we are taking the natural log. So log of this left hand side is equal to log of right hand side. So this log and exponential part will be get cancelled. If this 2v2 and 2v1 will come on the left hand side of the equation, so this becomes 2 of v1 v2 log of this particular is equal to this v1 and v2 x minus m2 x minus m1. Further simplification is done. Both the values take on the left hand side and assign that equal to 0. So this is just the normalization of the solving the equation in the equal to 0 form. Okay. Compute the exam score threshold to solve the below equation. So assume first, that is the red part, v2 minus v1. So these are our variance taken from the previous results. So that comes minus 28.31. Next is variance into mean for M2 and M1. This will come 83.54. For C, that is our V2 M1 square minus V1 M2 square. That is this blue part log to this particular. This blue part is termed as a C, and that result comes minus 45.7866. So putting this ABC values, that we need to compute actually the coefficients. So the solution of this quadratic coefficient with respect to x equal to standard formula minus b plus minus b square root of b square minus 4ac, and we got the values of a, b and c. ABC values from the previous slide, and we got the x equal to 72.72 or x equal to 222.4. This is out of our exam score range. Second point, this exam is from 0 to 100 marks, right? So the x1 will be, x is our threshold, that comes 72.72 marks. So any student with the exam score less than 73 will go for our regular class, right? And any student with the exam score greater than or equal to 73, 72.7. So more than 73 will go for the gifted class. So this is the example for Gaussian mixture model. Right? So mathematical equations, don't we get confused. Explanation of each and everything is provided here. So everything is explained clearly. This is the end for this unit number 5. So I'm going to end here. Tomorrow is Saturday, no lecture will be there, and from next week we'll take the presentation. That will be followed by few points which are remaining. Okay, that remaining points, and that I will continue probably in the second or third week. That's it for this today's session. Any doubt, confusion you're having, please ask me. If anyone is live or active, just I'm closing now. Nobody's there. Kanchan, Chaitali, Bhairavi, Mrinalini, Pallavi, Parikshit, Sujit,
Yes,
Vaishnavi.
sir. Yes, sir.
Uh, I'm stopping here.
Yes, sir.
End of minute number 5. Okay. Tomorrow lecture will not be there. Okay. Tomorrow, day after tomorrow, and next week also, your presentation will be there only. Next week we'll see that if there is any remaining point. Few of the remaining point are there, so we will elaborate that. Fine, so I'm closing now.
Okay.